A composite function is created when one function is substituted into another function. Okay, so this is a function f and this is a function g. So let's assume I have this function g in this function f. We call that a composite function. It's going to do something like this. So in this example, the function g is inside function f. So we'll call that a composite function, where we have a function in another function. So we are substituting the function g in the function f. So this will be f into bracket. The function g is 2x minus 1, right? So putting this now, substituting the value 2x minus 1 for x in function f. That is wherever we see x now, we put what? 2x minus 1. This will become 5 into bracket x now is now the function g, which is 3x minus 1. So 2x minus 1 plus 6. This will become 10x minus 5 plus 6, which will give me 10x plus 1. So I think you get the idea of composite function, where we have a function in another function. If, for example, we are given y equals to sine 5x, and we're asked to find dy dx, you have to differentiate this function. You have to differentiate y in respect to x. Okay, in the previous video, I explained something about the types of functions we have. I mentioned algebraic function, where we have 5x plus 6, 3x minus 1. They're all algebraic functions. And I also mentioned trig functions, trigonometric functions, where we have sine, cos, cosec, and the rest of them. I gave you something, let me just remind you. I said if we have y to be equals to sine x, dy dx, that's differentiating y in respect to x, we're going to get what? Cos x. And if I have y to be equals to cos x, differentiating this, dy dx will give me minus sine x. Okay, so basic rules. Looking at this question, we have to differentiate y in respect to x. You can see that the 5x part here, the 5x is an algebraic function, and sine is a trig function. So we're having an algebraic function inside a trig function. So this is what? This is a composite function, because you're having a function in a function. Sometimes we call this function of a function, where we have a function in another function. I think you get the idea now. So how do you differentiate this? When the previous example where I gave you something like we asked that fx is equals to 5x plus 6, we have to find the derivative here of the function. So we say this is raised power 1, so 1 multiplied everything, it becomes 5x raised power 1 minus 1, plus there's an invincible x raised power 0 here, so you 0 multiply everything, you have 0. So the derivative of the function will be equals to 5x raised power 0 plus 0, which will give me 5. Okay, so if I add this as y equals to 5x plus 6, so the y dx is also equals to 5. That means that this here and this means the same thing. So I have to find the y dx. So how do we solve this? What we simply do is that we represent the inner function using a variable. We introduce a new variable. So we say let the inner function, which is 5x, equals to a new variable which we call u. So we say let u equals 5x. Then we differentiate u in respect to x. Don't forget, where you differentiate a dependent variable in respect to an independent variable. So we say that du dx is equal to, when you differentiate 5x, what do you get? We get, this is raised power 1 now. So 1 of everything, you get 5x raised power 1 minus 1. That will give me 5 raised power 0, which is what? 5. So du dx is 5. Now coming back to our equation, we know that y is equals to sine 5x. And don't forget, we represented 5x already as what? As u. So you see y is equals to sine u. Again, I can differentiate this. I can differentiate y in respect to u. Okay, so dy du will be equals to, when you differentiate sign, you don't forget I told you up here, the differentiating sign of something will give you cos of that thing. Okay, so differentiating sign u should give me cos u. Now we're not asked to find the y du, or neither we asked to find du dx, we asked to find the y dx. Okay, now this is where the chain rule comes in. The chain rule says that dy dx is equal to dy du times du dx. So we call this the chain rule. It's called the chain rule. Okay, so what is dy dx now? Dy dx is equals to, what is dy du? We have dy du to be cos u, okay, times what is du dx? Du dx is 5. So this will give me 5 cos u, which will be equals to 5 cos, what is u? U is 5x, so 5 cos 5x. So dy dx is equal to 5 cos 5x. Okay, let's take a look at another example. Let's say we have y to be equals to ln x squared plus 6x. I'm going to ask to find dy dx. Okay, now again, we have two functions here. This is the algebraic function, and this here is a logarithmic function. Okay, so we're having a function in another function. We're having an algebraic function in a logarithmic function. So what do? We introduce a new variable, right, with the inner function, which is the inner function here. So we say, again, let u equals the inner function, which is x squared plus 6x. Alright, so differentiating u with respect to x, we're going to have du dx, which is equal to, simplifying this, 2 come to the back, right, it becomes 2x raised by 2 minus 1 raised by 1. This should give me 6x raised by 1 minus 1. So therefore, this will be equals to 2x raised by 1, which is same as 2x, plus 6x raised by 0, which is same as what? 6. So therefore, du dx is 2x plus 6. Now coming back to the original equation, this equation over there, we know that y is equals to ln x squared plus 6x. Now I can say that since x squared plus 6x is u, so I can say that ln u, this is y equals to ln u. So differentiating y in respect to u, dy, that will give me dy du. Now don't forget, if y is equals to ln x, dy dx is 1 over x. Okay, so if you are differentiating ln of something, dy dx is 1 over that thing. Okay, so differentiating ln of something, where something here is u, dy du will be what? 1 over u. Alright, we have to find dy dx. Don't forget, using chain rule, dy dx is equals to dy du times du dx. We call this chain rule. So what will be dy dx now? Dy dx will be equals to, what is dy du? Dy du is 1 over u times, what is du dx? Du dx we got 2x plus 6. So multiplying this, we have 2x plus 6 over u. So therefore, dy dx will be equals to 2x plus 6 over, what is my u? What is my u? My u was given as x squared plus 6x. Okay, Let's take a look at one last question. E is an exponential function and 2x plus 5 is an algebraic function. So we're having an algebraic function in an exponential function. What do we do again? We introduce another variable. So we say let u, which is a new variable, equals the inner function, which is what? 2x plus 5. So we differentiate u in respect to x. This should give me 2. Alright? Now bringing back the original equation, we know that y is equals to e raised by 2x plus 5. But 2x plus 5 is what? Is u. So this is e raised by u. So differentiating y in respect to u, that will give me dy du. So dy du, don't forget again that if y is equals to e raised by x, then dy dx is e raised by x. That is, if you are differentiating e raised by something, dy dx e raised by that thing. Okay, so this will give me e raised by u. Now we have to find dy dx again using chain rule. Dy dx right is equals to dy du times du dx. Okay, so therefore dy dx will be equals to, what is dy du? Dy du is e raised by u times du dx is 2. This should give me 2e raised by u. This should be 2e raised by, what is u? U was given us 2x plus 5. Now we can solve this. I think this is quite clear. We can solve these same questions using simple steps. Okay, we can solve this in less than 10 seconds. Okay, so let's take a look at the first one we solved from the beginning, where we said y is equals to 5 sine 5x. Now we solved this initially, and what did we get? We got this over here, that is we got 5 cos 5x. So how can we solve this in less than 10 seconds? Now identify, the first thing I have to do is to identify that this is chain rule. We have the inner function and we have the outer function. I love calling this the baby and the mother. So the baby is the inner function and the mother is the outer function. Okay, now what do you do for you to find the y dx without going through this process, all these processes? What do you simply do? First thing you have to do, you should differentiate the baby. Okay, then differentiate the mother. Let me come again. Differentiate the inner function, then differentiate the outer function. Then multiply the answers. If you differentiate the inner function, what do you get? You get 5, right? Now, if you differentiate the outer function, what's the outer function? Sine this. Let's say sine something. Okay. Now, don't forget, I said when you differentiate sine something, you can get over here. When you differentiate sine something, it gives you cos of that thing. So, differentiating sine this thing, that's sine 5x, will give you what? We should give you cos that thing, that's cos 5x. So our answer is 5 cos 5x. You can see we're able to get the answer even without going through all the steps. Okay, let's take a look at the other one we solved. This where we said y equals to ln x squared plus 6x. Again, the concept here of solving this in 10 seconds is that you identify the mother and the baby. Okay, so the baby is the inner function. So look at the inner function. What do you do first? Differentiate the inner function. When you differentiate the inner function, where is the inner function? The inner function is x squared plus 6x. Differentiate this should give me 2x plus 6, right? When I differentiate the inner function. Then differentiate the outer function. What is the outer function? Ln. Don't forget, I said when you differentiate ln something, it gives you 1 over that thing. That's just a little way of remembering. So differentiating ln this will give you what? 1 over this, which is 1 over x squared plus 6x. So when you multiply, you get 3x plus 6 over x squared plus 6x. So that's how we easily get the answer without going through the entire step. This is even less than 10 seconds if you take a look at it. Now look at the last question where we have y equals to e raised by 2x plus 5. Again, you get the idea already. We have the inner function 2x plus 5 and the outer function e. So what do we do? First, we have to do is to differentiate the inner function, then differentiate the outer function. If you differentiate the inner function, that's 2x plus 5. What do you get? You get 2, right? Now differentiate the outer function e. E raised by something will give you e raised by that same thing. Okay? Differentiating e raised by this will give me the same thing, e raised by 3x plus 5. So multiplying, we're going to have 2e raised by 2x plus 5.